Okay, so a very typical proving then solving question. All right, so what we have here is that they want us to prove. So the left side surely looks more complicated. So what I'm going to do is when I see a fraction like that, right, what I like to do is I always like to split it up. Tangent A minus cotangent A divided by tangent A plus cotangent A. Okay, so then I see my right side only wants cosine. So who wants tangent? Nobody wants tangent. Nobody wants cotangent as well. So this is sine A over cosine A minus cotangent is the tombalik of tangent, right? So cosine A over sine A from here. Okay, so then we're going to divide accordingly. So usually when you do this, you'll be able to cancel something, right? Okay, I'm just going to copy paste, okay? Smart, right? Okay, so I'm going to divide. This is a plus like that. But I want to simplify each of the bracket. To simplify each of the bracket, I need to make their denominator the same. So what I'm going to do is this one here, my common denominator will be sine A cosine A. So the first one is missing a sine, so sine square. The second one is missing a cosine, so cosine square. Okay, then we're going to divide by. Similarly, we also have this one here, just that this one is now a plus. Okay, okay, so then from here, right? So what I'm going to do is I'm going to do my primary school way, which is I'm going to change my divide to times. Okay, so then I'll change it to sine A cosine A over this thing. Okay, then after that, when we see this part already, right? This one here, you can see. So very typically, when you do something like that, right, you can actually simplify accordingly one. All right. So we have sine square minus cosine square. Then we have sine square plus cosine square. So the thing about sine square plus cosine square is actually 1 there. Okay, sine square plus cosine square is actually equals to 1 based on the identity. All right. Then that sine square minus cosine square thing looks very familiar to me. All right, but what I have is maybe we can see whether it looks like this one here. I squeeze here, okay? Okay, so when the denominator is now 1, right? What happens here is that I'm just left with sine square minus sine square A minus cosine square A, right? Just like that only. I got nothing in the denominator, it's just over 1. So then when I see this, do you realize that it's tombalik of this thing? So because it's tombalik of this thing, what I can do is I will just go and factorize out a negative if I can. All right. So if I factorize out the negative, right? Or I can swap it around, for instance. So what I can do is, okay, let me think. Oh, maybe actually if I don't, okay, let me do something simpler, okay? Okay, so maybe I can use identity. So we don't need to swap here, swap there. I scared you get confused. So maybe we use with this one. Because you see the top, right? The top question, right? Only, I mean the right side, only wants cosine square, right? So if it only wants cosine square, what I'm going to do is I'm going to get rid of the sine square. Lah. Two ways to do it, okay? So from here, this is 1 minus cosine square A. Then the other one is minus cosine square A, right? Okay, this is much easier. So minus minus, so 1 minus 2 cosine square A. All right, if you can do it this way also can, because you are doing sine square minus cosine square, so it becomes 1 minus this. Straight, either way is fine. All right, I prefer this. I think as a student, I would prefer this as well. Okay, so this one is the proving one. All right, so now that we are done, what I'm going to do is I'm going to solve, hence solve. So the hence part here is, oh no, they don't look the same. Oh goodness. The A, this is 2 liter, 2 liter, 2 liter, right? So if this one is A, so that means if I were to change this one, right, it will become 1 minus 2 cosine square 2 liter equals to half. Can you see that? Okay, so it swapped already because just now that one was just A, everything becomes A, right? So my angle is different. Okay, now I'm in my radian mode. You can tell it's radian mode, right? So the thing is you have to give your answer in terms of pi. Actually, for me, right, It depends on how you want to do it. If you can find it in degree, it's also okay. I'll show you later, okay? Okay, manipulate first, So bring over. Minus 2 cosine square 2 theta is equals to half minus 1, which is negative half, which allows me to remove both, to divide by negative 1 on both sides. Okay, then what I have here is that cosine, I want to make it, oh my God, wait. Cosine square 2 theta, right? So I'll divide by 2, that is half. So from here, I got cosine 2 theta equals to square root 1 quarter and also equals to negative square root 1 quarter. Can you see that? Okay, we're going to start with the basic angle. I'm going to show you how I do it in degree, okay? Because if they never say in terms of pi, I just do it in radian, just 3SF, 3SF all the way, right? But now they want in terms of pi, so I try to do it in degree. So what I'll do is I'll determine step 1, no change 1, okay? Step 1 is always your quadrant. So we are solving for quadrant. Cosine positive here, cosine negative here. Okay? But for both of them, please understand that their basic angle is the same. We never cosine inverse a negative number. So I'm going to do it in degree mode because I'll be able to get a nice number which is 60. So cosine inverse half is 60. That means I will understand that, okay, 60 is pi over 3 because pi is 180. So if I did it in radian mode, right, I show you, okay, cosine half, right, I'll get this ugly thing, right? But what you can also do is you can divide it by pi, so you know that it's 1/3 of a pi, so you can put pi over 3. But I like to use degree because it's like so nice. I can just count, but only if they ask me to leave it in exact. Otherwise, you just 5SF, 3SF, okay? Okay, so now from here, I will have 2 theta. What cycles do they want? They just until 1 until pi, Okay, so first quadrant is pi over 3. Second quadrant is pi minus pi over 3. Third quadrant is pi plus pi over 3. Last quadrant is 2 pi minus pi over 3. So from here, simplify further. So this is pi over 3. How do you calculate this one? Don't press pi. Press 1 minus 1/3. Then you will get, 2 pi over 3, like that. Okay, don't press the pi in. You press the pi not exact anymore. This one 1 plus 1/3, which gives me 4 pi over 3. Then this one here is 2 minus 1/3. I think it's 7. Let me check. Ayo, 2 minus 1/3. This, 5. Okay, 5 pi over 3, like that. Then from here, you need to find x, right? So to find theta, just divide. So this is pi over 6. 2 pi over 6 divided by 2, right? This is 4 pi over 6. This is 5 pi over 6. So one thing we can simplify here is that this one is pi over 3. This one here is 2 pi over 3. All right, but the technique is the same. So then from here, I think whether I need another quadrant, but they want until pi only, right? So you can just check from here. Pi, if you're not confident, right? What's pi? Pi is 3.14 something, So you press 5 over 6 pi. 5 pi over 6. That's smaller than this one. So that's nice. All my answer will be here. So the technique to learn here is if they want exact, right? That means your answer sure nice one. So what I will recommend is you can do in degree. Once you get your degree 60 ready, right? So in radian mode, it will just be pi over 3. Like that. If it's like maybe 45, then that's pi over 4. If it's like 30, then that's pi over 6. Okay, so get used to all these numbers from here.